Heavenly Father, thank you for your loving kindness today. And thank you for your help, my life. And I reckon that you've helped some of these in this classroom even today. You're amazing to do that. And I pray you continue to, Father, that you would just open us up to receive every bit that you have for us. You can do that. And I pray you would. And Father, they're speculating about a flood coming up. Well, you know how that disastrous it can be when people build in floodplains and people live close to rivers, and what's happened the last couple of times has happened, and I just pray you give grace to people, Father. You'd help them to move when they need to, if they need to, and take care of business, Father. You can lead people so harm doesn't come. You can give them wisdom and grace, and I pray you do that. Whether they're Christians or not, you can help them, and I pray in Jesus' name. Amen. Amen. Don't do that when I'm praying. I'd appreciate it. Oh, sorry. Yeah, I just appreciate that. So, this is, I'm going to go over the papers that I passed back, but right now I'm just going to touch on this because it's on the screen. So I was looking at, I was reading articles about earth science, and I came across this guy, Antonio Snyder. That was all his name was. And so I later found out it was Snyder Pellegrini, but anyway, I'd never heard of this guy, so it was quoted in a creation article. And I don't care whether they're Christian or non-Christian. Christians don't pay attention. I mean, I got a video that was a horrendous video. Somebody being burned because they'd stolen something. And the person that said it was from India. And this is what they're doing in India. Well, it happened, it was Honduras, and it was years ago. So they didn't check it out, they just forwarded it. They just sent it out. So it went out to all kinds of people about what was happening in India, and it was horrendous. Except it wasn't India, it was Honduras, and it wasn't then, it was back in time. Don't do that. I mean, people are doing that. Christians are just sending stuff because somebody sent it to them, and it sounds good, it feels good, or it elicits emotion. Well, I'm against it. I just don't think it's profitable. And so to check out what Christians are saying, even ICR or Answers in Genesis, I just want to be confident that what they're saying, and if I'm gonna be communicating in the class, then I want to be as sure as I can be that it's reasonable and that it actually happened. So anyway, I found who this guy was, and so I thought, well, I'll check to see if he was really one of the first people to come up with this plate tectonics idea. And so I Googled his name. Well, I got all kinds of references, and so I went after him. Secular, non-secular, I just went after to see what they said. And so after going around a number of these things, and getting an idea about people saying consistently the same thing about him, whether they're Christian or non-Christian, then it started to make sense that this guy was legit. Some of the stuff I read, because they mentioned a lot of other people in his same, these guys or these women also talked about plate tectonics or the earth moving or some kind of had their hands in this theory in some way. Well, I looked at them, and some of them I had to read English translations of the works because they're done in German or some other language. But I did that. And so some of it, if I looked at it, I could say, okay, these people, while they mention it, they don't get deep into it. It's like a sweep and a promise, just on the surface, and some of it really dig deep. So it took a while to find out who was on the same level as this Pellegrini. And he had it tagged pretty well. And so when I came across, it was profitable for me to do this. That's what I'm doing. So I weeded out names that people had a bit of information, but not a lot. Benjamin Franklin. These guys back then, I mean, they were doing things, they were leading armies in their early 20s. They were doing incredible things. Well, Benjamin Franklin wrote a letter to some guy in France. He was corresponding with him, and he wrote a letter about this guy had written him, and he was responding back about how he thought the crust of the earth was somewhat movable. I mean, he's thinking about all kinds of things. He wasn't just specializing, but he was thinking about, I have some stuff on him, I won't bother to go into that. I've got another lecture, but we don't have time for it, I don't think. Anyway, looking at what people did helped me to weed out the ones that just mentioned something in passing and some people that dug into it. And there is this that I am going to show you. It's brief, it's just a couple of minutes, but it talks about this guy.
In 1858, the scientist Antonio Snider Pellegrini published an interesting book. In it, he expressed his observation that the continents of the world look as if they fitted together at some point in a large jigsaw. These ideas have been propagated over the last 50 years or so with the concept of continental drift or plate tectonics. But this slow-scale process is not what Pellegrini had in mind. Pellegrini was a Christian and believed the book of Genesis to be true. And his ideas were ignored at the time because people were already moving away at that time from biblical concepts of geology with the publication the following year, 1859, of Charles Darwin's Origin of Species. Pellegrini noted, though, that in Genesis chapter 1, God says that he gathered the seas into one place. The implication, therefore, would seem to be that the land was in one place also, in one continent. Today we think that the crust of the earth must have split open in a mechanism that we call catastrophic plate tectonics, which helps explain how the flood may have come about. In Genesis chapter 7 we read that the flood was started by the opening of the fountains of the deep. As the crust opened then, water from beneath the crust, and the seawater maybe as well, would hit the mantle and would be superheated. This volcanic activity is the fountains of the deep. But the water would have been thrown into the atmosphere at supersonic speed and would have created a storm pattern over the entire globe, with water falling over the entire globe, and this is probably what's meant by the windows of heaven. So this mechanism gives us an explanation as to how the flood could have started, and the continents would therefore have moved apart very rapidly while still submerged, with the current continental pattern probably emerging underwater within about 40 days of the beginning of the flood.
So Pellegrini had an idea that about plate tectonics quite early in, well, not in geological time, but so, and I don't know that I hope you'll see it as we go on, but there are so many factors. The part of plate tectonics moving and moving rapidly, like the spreading of the earth, continents spreading, like Winnegar hypothesized. Well, to do that in a rapid way, now evolutionists will say, yeah, it happened, but it happened. In fact, they have said, some of them have said it has happened many times. That we've had it spread apart and come back and spread apart. A lot of, just like some of them has hypothesized there have been floods, but there have been like not only the Missoula flood that wiped out eastern Washington, took the topsoil away. They said there have been many floods. But nonetheless, for rapid subduction, and we're going to get to a guy that did some studies on this. They have found, when they've taken seismic studies of the interior of the earth, they found their bodies of mantle, or the bodies of lithosphere that have subducted and are colder by a couple degrees than the surrounding, and a couple degrees is significant, apparently. I couldn't tell you that from my experience, but apparently people that do that say it is. So there are masses of colder stuff that would be consistent with crusts subducting rapidly, like miles per hour, subducting under, causing great havoc. I think I said last time, Noah wasn't just, he wasn't drifting idly by, you know, sun shining and everything. I mean, that he must have been in a tumultuous kind of experience. So I passed back media papers, didn't I?
Mm-hmm. Yes.
So, and I believe, I'm sure I said this before. So you've had 2 media papers, you've got 2 more. And if you want to write very briefly, you can do that. It's up to you. But your grade is up to you as well. And if you write the minimum, that's what you're going to be graded on. Now, some of these, if you gave me what I understood to encompass what was said in answer to what I had answered these questions, I gave you credit. But you had 6 questions. And 6 questions, and unfortunately, when I redid these, when I redid medium 1, medium 2, it's mine. I usually shut that off. Well, oh, there we go. There we go. Sorry, I apologize. So usually on the first 2 that you've done were revisions. I didn't, the stuff was old. I thought we'd done something more current, so I did. And when I put 125 points on these things, I wasn't really thinking so much, I was thinking more of an essay, because that's what you had to do before. You had to write more of an essay than just answer questions. So 6 questions divided into 125 points is 20 points a question and 25 at the end, something like that. I mean, that's significant. So you give me 2 lines. You give me 2 lines, but you better cover everything in 2 lines. I would encourage you, because what I want you to do is think about some of this. So what I have, I'll just give you what I have. It didn't have to be exactly, some of you will see, it didn't have to be exactly for you to get full credit. But it says, according to what this video presents, what is the foundational idea behind the assumptions of intelligence? Well, it tells you. He tells you up front. Intelligent design, and some of you got this exactly. In fact, some of you got all of these, just exactly like I had asked them. And it isn't out there. It isn't out there somewhere. I've not done this one before, this class. So some of you were able to ferret out the answers just exactly as what I expected, which is an encouragement that it could be done. So intelligent design, the idea that there are certain features of the universe that are best explained by designing intelligence rather than undirected, unguided processes like natural selection. So that's what I was expecting. You could have made this brief, but if it was brief, you probably got a score that wasn't full. And some of this, Dr. Meyer comments on Darwinism. What does he say about it? And how about natural selection? Well, this first part doesn't. The first sentence is, but this, after this, it does a great job of explaining small scale modifications, and he describes them. He gives me a description. So you know what he's talking about, not just, so somebody that read this could tell what he's talking about. And then he does say, he said it's a really bad job of explaining origin of birds and animals in the first place. Natural selection. So this part here, 2 sentences. Or 1, 2, 3 sentences. That was what I was looking for. If you said some of that, I would certainly give you credit. But that would be a complete answer. It says, what does he say about it? And this is what he said. So if you collapsed what he said and gave a summary, if you gave a summary and touched everything, then that's okay. But if you didn't, if you just gave a simplified statement, if it wasn't responding to what he said, then you probably didn't get the points that you would have otherwise. Now, if you feel that you weren't graded correctly for this, you can, I'd appreciate you talk with me. I'd be happy to. Nobody has so far. Only a couple people have called me and asked questions. But the people who have called me and asked questions have gotten answers, I believe, that were helpful. So you can do that. This is part of the deal of being here. I'm open. I want to be open to your calling. I'm not inconvenienced. So this one, Dr. Meyer also mentioned modern neo-Darwinian theory. What does this theory assume? So you could give a short and sweet answer to what it assumes, and some of you did, but what it assumed was the first creature was probably a single-cell organism that formed probably in the ocean, and somehow this creature would have sustained itself long enough to eventually reproduce. As generations of offspring were created, beneficial mutations of their DNA would eventually create more complex features such as arms, et cetera, eventually all the species we have today. So that's what this neo-Darwinian theory says. If you didn't say that, some of you said it was probably a single organism formed in the ocean. Well, that is certainly part of it, but it's just a little part. It's not the part. If you put it down as the part, then you got responded to accordingly. Number 4, this was stated in the culture we have, in the epidemic of both suicide and opioid use. What is suggested as driving force behind these issues? So the books, or the videos assumption was that it was the angst in the culture, in a sense that there isn't or can't be an ultimate being in life. So that's what they assessed. Then do you think it's reasonable? So I'm turning it on you. Do you think that's reasonable? So I would have liked a thoughtful answer. So what they think and what you think, in fact, I spent a long time working on an answer to somebody that wrote that it took me a while to grasp what they were saying. Well, I think I did. But anyway, to reiterate what this is not on here, it's probably better if I put it on here, but they think, Meyer, I think it's reasonable. They didn't say it was the driving force, contributing. I think it's reasonable that it could be contributing. This opioid use, increased suicide. If you're looking at life from the perspective of naturalistic materialism, which has no driving force, no goal, it's not goal-oriented, and there's no intrinsic value to human life, well, I don't think there's many conclusive studies that say there is a direct correlation, but to say that there's some possibility of an influence. I did drugs and drank heavily for 10 years. I wasn't an alcoholic and I was never a drug addict. But I shot and snorted and popped and smoked. I just did that a lot. Was I thinking, oh, there's no meaning to life, I'm gonna do drugs and drink heavy? No, I don't remember ever thinking that. I don't remember that going through my head. But my life was empty. I had lots of money. I had friends. I had stuff. But internally, I didn't like my life. And I wanted something that would give an intensity. And I thought there was something that would. And in the meantime, I just drank heavy and did drugs. I didn't do it when I worked. And I worked hard and I made good money, really good money. But it said that wasn't getting it. And when I finally found Christ, the first two things that he did, and he didn't tell me not to drink, and he eventually did, several months later, but he never told me not to do drugs. But I didn't want to do either one of them after I met him, and I didn't have any Christian background to tell me you shouldn't. I didn't know you didn't fornicate, I didn't know you didn't do drugs, I didn't know you didn't drink, I didn't know any of that when I became a Christian at 29, because I never met one. I never met one person that professed to know Christ in my life before I was 29. And after I made a decision to follow Christ, then I met the first Christian. Now, I'd been reading the Bible, but I never met one. So my experience with this, I was aware that there was something empty, but I had ruled out Christianity. I mean, from my exposure to it, it was pitiful. And but God gave me personal value in my life, and he gave me a meaning for living that's 48 years old, almost. And it's more real now than it was back then. Actually, 48, going on 49 years. So it'll be 50 years ago, next June 1st, 1976. Not the next one, the one after that. That'll be 50 years ago I made that decision in an automobile to follow Christ. And it is better now than I would have ever imagined. I couldn't imagine it'd be like this. Life has meaning, it's rich and full, and it's not a function of circumstances, who I'm working for, what I'm doing. It is just, and I've had almost 50 years, 48 years, to see if it will. And it has, and I mean, I am having the best days of my life. I'm not thinking as clear, I'm not thinking as fast, but the joy of life is legitimate and genuine. Well, that's what Christ gave me. Those are the two most important things. And he didn't give me a list of do's and don'ts when I got saved. I mean, I didn't have any idea. But I woke up in the morning, I didn't want to get drunk. I thought, oh, I didn't want to get high. I had some friends that went out, said, the first people I met, they were going out and getting high, going up to the Blue Ridge. They wanted me to go, well, I went with them. So they were smoking. I guess they were just smoking dope. And I just didn't feel like doing it. I didn't. It wasn't that God said, you can't do that now. You're a Christian. He didn't say that. But I didn't want to. Life started to take on meaning. And it wasn't a function of me getting blinded by other stuff. So I had 10 years of experience in this stuff. And I mean, I considered suicide, I think, 2 or 3 times in my life when I was in high school. That I thought about it more than just, I didn't. But personality-wise, I'm not inclined that way. I'm pretty out there. My sister keeps everything in, but it's out there before. Anyway, I've learned to exercise some self-control most of the time. So, what does this guy describe, Dr. Jonathan Wells, as adaptation? Well, he said, it just means the ability of an organism to change to fit its environment. That's what he says. And as a biologist, what did it tell him? Well, it tells me that they are incredibly well designed so that they have the ability to adapt to their environment within limits, of course. So not everything. I mean, it's not like, okay, now it can adapt, it can do everything. Well, there are limits. He understands there are limits. And then the last one, and this, I think I had more lame excuses to this. Some just got religious. And the question was, according to what this video presents, would one need to be a Christian to believe in intelligent design? Well, no, they wouldn't. Because the foundation behind intelligent design movement does not point to a specific creator. It points to an intelligence that reason suggests had to have designed what we're discovering in nature. I mean, that's life is much too complex to accommodate the idea of an unguided and godless process and random mutations in its creation, even at the most rudimentary level. So I took a lot of different stuff. This was worth 25 points, the rest were worth 20 points, so whatever, I usually put what you got over the mark that you had a possibility to get. And I'd be happy to address, if you want to talk to me after class or sometime else about what you got and why you got it, and I'm happy to talk to you about that. Okay. So, if you have any questions, you can talk to me. So, the next one that you have, and I think there are a bunch of questions on that one. I think, number 3, yeah, there are a lot of questions on this thing. So, oh, that's something else. Yeah, that's it. Yeah. So, I gave you background on this, and then there are a bunch of questions. And these aren't exhaustive questions, but I encourage you to write thoroughly. If the answer is only a couple words, then that's all you need to write. Some of you actually wrote very shortly, but you encapsulated what I wanted for the most part. But when you carried it into some of the longer questions, you just did a short one, and that it didn't work as well. Any questions about that? I want you to do well, and I want you to think about this stuff, so that's why. And so this is the end, this one. So we didn't get to that. I think I did put this on. Lessons? You got that?
Yeah, I'm looking at it.
Okay, so I put this one on lessons. So you have this. This is important. I just wanted to bring up this. This is important. Plate tectonics transition from a hypothesis to widely accepted theory by the mid-1960s. I remember for Christmas, I asked my parents to give me a magazine subscription to Science. What is that name? It's been around for years and years. Anyway, Science magazine, and I remember in the 60s. I think this said 68, whenever it was, and I was getting that magazine, and I was just entranced with this idea of plate tectonics. I mean, I wasn't. Anyway, I remember that. Scientific American. Excuse me. It was then that evidence supporting the seafare splitting solidified the concept, effectively merging with Alfred Wegener's early continental drift hypothesis to form the modern theory of plate tectonics. So you had seafloor spreading that was enabled by Marie Tharp and those that were working in that arena. It wasn't just Hess. You don't see Marie Tharp mentioned everywhere. She was at a contributing point, but there were other things that were involved in this thing, and there still are. Some creation scientists are doing studies on rapid subduction. Baumgartner, we're going to talk about him. And so they're taking pieces of this thing, and so, okay, if this would happen, if we would expect secular science said, well, this is the way things should happen. But as creationists, if we were thinking, okay, if we believe that God did this, and this happened the way it says in Scripture, what would we expect to find scientifically? And it's not just one thing. It's what would we find in the inner part of the earth? What would we expect to find? Where would we expect to find fossils? What would we expect the earth to have been changed by? And how would it be changed? So many things, so many parts of this are this thing. It's not just, do the plates move? I mean, why like the study, they had to figure out not only spreading seafloor, but the magma of not boiling, but what the heat inside generating the movement of magma within the earth, that whole deal was part of coming to this conclusion. There were many pieces to it. So, well-established explanation supported by substantial evidence that describes how the Earth's tectonic plates move and interact, and in the process generate phenomena like earthquakes, volcanoes, and mountain building. That's what they were expected to do, and that's what they do. And creationists certainly will say the creationist model describes this better than the evolutionary model. For a number of reasons. I might give you extra credit by watching this. It's not very long. 15, 20 minutes, I think, this DNA thing is so interesting. The guy says you just can't. You can take the population and how they know about genetic mutations and what they do and populations, and there's just no way we could have millions of years, even from there, but that's the, anyway, okay. So I've turned these back to today. Okay, same kind of thing. I wanted complete answers, or I wanted answers, and some of you mentioned the Mesosaurus, but you did it so briefly that it didn't indicate, I mean, other than, well, the Mesosaurus, they're fossils, Mesosaurus fossils. Well, the fossil remains of these things are located only in areas of eastern South America and southwestern Africa, areas that appear to at one time fit together according to continental drift. So they found the remains of these things. They didn't find, some people said from what I read, you would think that these guys were still, these Mesosaurus were still around. And they were just kind of chilling in these two different places. Well, they're not. It's their remains. The fossil remains of these things are only located in these two parts that were once together. That's what's significant by this thing. So that was 4 points. Well, you can see. What are the three major types of boundaries? 1, 2, 3. Convergent, divergent, convergent, transform. Then you have these boundaries, divergent boundaries, and convergent, transform. And I wanted to know why, what action taken. In divergent, the plates move apart, they diverge. The convergent, they move together, and transform, they move side to side. I hope to illustrate that. So we won't have class on Monday, we have a study day. So the next thing that is due is media 3. So, what exactly happens? What exactly happens when divergent plates move apart? This is science, so more detail is expected in science. It's detail oriented. I don't know why I would be the one to teach it, but apparently that doesn't matter to the Lord. So, where plates move away from the ridge axis and the fractures created are immediately filled with molten rock that comes up from the hot mantle. In a continuous manner, successive plates spreading and upwelling of magma add new oceanic crust between the diverging plates. So when you have divergent, you have new crust being formed. And when you have divergent, when you have divergent, new crust is being formed. It's pushing apart the crustal, oceanic crustal crust. And when you have convergent, it consumes, it's consuming. You're creating seafloor and you're consuming it at the convergent boundaries. You've got subduction going on, it's consuming. And so there's a question in here about why, well, we'll get to it. I guess we'll wait till the end. So, where is active seafloor flooding? This is on, page, I don't remember what page. Could have been 218 or 19, if that was a section. I'm not sure if that was a section. It was there. So it says, where is active seafloor spreading occurring today? Mid-Atlantic Ridge, Eastern Pacific Rise, and Mid-Indian Ridge. Now, Iceland is on the Mid-Atlantic Ridge. If you look at the little picture, in that thing, they showed Iceland, and they showed a line, and their stuff was happening because the mid-Atlantic ridge just goes through Iceland. So if you said Iceland, well, active sea floor spreading is occurring. The only reason it's Iceland is because Iceland is on the mid-Atlantic ridge. I might have given you a point, I can't remember if I did or not. Anyway, Eastern Pacific Island, 3 things were mentioned. Most of you got these 2. This one was in there. I mean, it was right, it was. And then what's the subduction zone? Region where oceanic plates descend into the mantle. So that's where, oh, don't do that. There. What kind of boundaries associated? Convergent, where plates move together. So the asthenosphere is where a lithosphere is being conjured. It's either the upper mantle or the asthenosphere. They call the upper mantle the asthenosphere. There is the mantle, but it's the upper mantle when that stuff is, where that stuff is happening. The asthenosphere or the upper mantle. I would assume you'd get a question like that going forward. Just, I would assume. Why must the production and destruction of lithosphere be going on at the same time? Because there's a constant surface. The surface area of the Earth is fixed. It just happens to be. That's the way that it was created, it's fixed. So when you get the production, you have to have something correspondingly consume it. So if you had rapid subduction, you'd have rapid production of seafloor, and you'd also have rapid consumption of it at these places where, at the plate boundaries, where the oceanic plate would go under the continental plate. And we'll talk about that. And then differentiate between transform faults and the other 2 types of plates boundaries. Many of you just put transform plates. All you did say was happen to transform plates. And they are, where plates slide past each other and lithosphere is neither created or destroyed. So there's no destruction of the lithosphere, but divergent, where plates move apart and lithosphere is created, and where plates move together and lithosphere is destroyed. So this is happening in tandem. They slide past one another. Some predict California will sink into the ocean. Is this idea consistent with? No, it's not consistent. It's not going to slide into the ocean. It's going to move away. It's going to move up the coast. So it's not going to sink into the ocean. The part of California west of the fault zone, including the Baja Peninsula, will become an island moving northwestward. So it'll move up and away from the coast. Well, a couple million years, it'll be out there. Outside of Seattle, maybe. They can make a bridge to it, be crazy altogether. So what are the 2 main driving forces of plate motion? Cold, this is slab pull, and ridge push. That's 2. What are they? Driving forces, and what are they called? So some of you just listed what they were called, but you need a little more detail on that. Slab pull is when dense slabs of oceanic lithosphere, more dense than the underlying warm asthenosphere, that is pulled down into the mantle by gravity. And ridge push is gravity-driven mechanism result from the elevated position of the oceanic ridge, which causes slabs of lithosphere to slide down the flanks of the ridge. So, just saying, you won't have to know that forever after. In your whole life, you'll never have to know that. Okay?
Reverse psychology?
Huh?
Reverse psychology?
Yeah. Well, you can use it there. I guess, if you want to. Whole mantle convection, cold oceanic lithosphere sinks or subducts to great depths. The core mantle boundary, and stirs the entire mantle. This downward flow is balanced by buoyantly rising mantle plumes that transport hot material toward the surface. And it's interesting that water, well, water, moisture. As the slab goes down, it collects moisture, and that's what helps to generate the melting process. So, if you have any questions about that, you can see me as well. But that was that. Now, 1, 2. Okay, here's the one that you were passed out last time, plate tectonics. The mapping of the ocean floor. Research existing using extensive data on seismic activity. That's important to know. Seismic activity has really been important in discovering what's going on underneath the surface of the earth because we don't know. We don't know, we can't see, we haven't drilled through the crust. So, the study of Earth's magnetic field combined with Wenger's continental drift hypothesis in 15, and Clark's work mapping the ocean floor in the 50s, Hess's seafloor spreading hypothesis, late 50s, the theory of plate tectonics. And you had others that were contributing. Pellegrini, way back in before Darwin, Pellegrini was there, and they were building on this thing. So according to the plate tectonic model, the upper mantle, along with the overlying crust, the lithosphere, acts as a strong, rigid layer that overlies a weak, more plastic layer, the asthenosphere. So you've got the uppermost mantle, which is the lithosphere with the crust, is a rigid layer, and that overlies a weak, more plastic layer, the asthenosphere, which accommodates movement. So plates, lithosphere is broken down a number of segments called plates, which are in continual motion over the asthenosphere. So that's not just the Earth's major plates. We could have done better with this, but nonetheless, you can look in your book, and it shows you the major plates. North American plate, you got this little plate here, right around coast of Washington up there. This is a Juan de Fuca plate, Caribbean plate, Cocos plate, Pacific plate out here, Natchez plate. They theoretically, they have all these plates. Some of them are moving in all kinds of directions. This one, the Juan de Fuca plate, that has all kinds of stuff going on. It isn't just subduction or divergence or fault movement side to side. It's not any of those, it's all these things. So this is just a general, you've got major plates and minor plates, and they're moving differently. Plates change in both shape and size as they move. Movement usually averages the neighborhood between 2 and 8 inches a year. There are 7 major or large sized plates: North American, South American, Pacific, African, Eurasian, Australian, and Antarctic. So there are 7 of those. 6 intermediate ones listed there, and then over a dozen smaller plates that have been identified. The movements of these plates is believed to be driven by, you will probably see this, you'll be driven by the unequal distribution of heat within the Earth. So,
it happens because hot rock rises, heated by the Earth's core. Near the surface, the rock spreads in 2 directions.
divergence,
It begins to lose heat.
convergence,
Eventually,
subduction.
much cooler rock ultimately causes the continents to move. Where the plates collide, the rock on the seafloor containing carbon from the dead plankton is carried deep into the Earth. As it descends, this layer of rock is heated, so the rock melts, releasing carbon dioxide. The gas is returned back into the atmosphere during an eruption. The remarkable cycle is complete.
So,
Heated by the Earth's core. Near the
So
surface,
rising magma,
spreads in two directions.
and you have divergence,
goes sideways.
you got this pushing
Begins to
this
lose heat.
apart, and this is
Eventually,
subducting.
the
This
much
plate,
cooler rock
oceanic plate
sinks back
subducting
down.
under a continental plate, for example.
Through this spreading process, the Earth's crust is very slowly dragged apart. And it's this that ultimately causes the continents to move. Where the plates collide, the rock on the seafloor containing carbon
And this
and plankton
would build up,
carried
this
deep
would be
into the
pressed down, and when it snaps back, you
As it
get
descends, this
earthquakes,
layer of
you
rock
get a
is
tsunami,
heated,
you get a
so
lot
the
of different
rock
things when that
melts,
just,
releasing carbon dioxide.
like a pencil, one top word, it'll start to just snap.
Return back into the atmosphere during an eruption.
Okay. So, this action, tremendous grinding of the Earth's lithospheric plates, it generates earthquakes, creates volcanoes, and forced rock upwards into mountains. All major interaction among the individual plates occur along their boundaries. So it's the boundary of the plate. The plate may be shaped, could be shaped like this, and it's on the boundaries that you'd find movement. Plate boundaries are differentiated by the type of movement they exhibit and are classified into three main categories. Okay, we covered that, we just mentioned that earlier. Divergent boundaries, transform fault boundaries, and convergent. Divergent, pushing up, going apart, convergent, coming together, transform side to side. So convergent boundaries, you can have an ocean floor going under a continent, you can have ocean floor going under ocean floor, and you can have the collision of two continents. So those are all convergent. You can have two continents coming together, you can have two ocean floors coming together, and you can have an ocean floor coming under a continent. So three parts of convergent boundaries. Each type of boundary has a characteristic pattern of earthquake distribution and rock motion. And each plate is bounded by a combination of different boundaries. I think I have, yeah, that one. So these are very simple. Your book has these. Divergent, moving apart, convergent, moving together, transform, going side to side. Here is, this is in the Cascade Range. So this is right off, this is a little piece of Washington. This is a Strait of Juan de Fuca coming down into, this is, Seattle is right here. So you've got these arrows are meaning this Juan de Fuca plate is subducting under the continental plate. The North American plate is here. This is subducting. We've got all these mountain ranges. I mean, 12 to 14,000 foot mountains. It's great if you like mountains. The Northwest is where to be. It's nuts politically, but as far as beautiful mountains, Mount St. Helens is here. That's Mount Adams. Mount Baker is, one of these two is Mount Baker, Mount Rainier. I lived close to Rainier Avenue. You go out to Rainier Avenue, you look right down the road on a clear day and you can see Mount Rainier standing at 14,000 feet. It's pretty. So, this is subducting. But these are divergent plates, right here. These three parts are divergent. So this is going this way, this is going this way, and these are transformed. You've got transform, divergent, transform, divergent, transform, divergent, transform, and then transform and subducting. So just in that one little plate, and that's where this subduction acts on this whole Pacific coast, subducting this oceanic crust underneath, and when it gets down here and it begins to liquefy, you have the building of mountain ranges. So that's what happens. So that's an illustration of that one. That's a little teeny plate. It's not even mentioned on one of the intermediate or small plates. It's smaller than that, and it's got all this action going on. Okay, I don't think we need a song. So divergent boundaries, there are two types generally. Oceanic, continental, that's divergent. Most divergent boundaries are situated along the crests of ocean ridges, referred to as seafloor spreading. Mid-Atlantic Ridge is an example. So that you've got seafloor spreading. That's what the Mid-Atlantic Ridge is, what Marie Tharp mapped out, so people could see from the soundings they took of the seafloor that it wasn't just flat mud, but there was a mountain range with a big trough in the middle of this thing, and that's what she was involved in mapping out. The thickness of the crust averages between 2 and 9 miles thick, and it thickens as it moves away from the divergent boundary. So it's thinner there, it thickens as it moves away, and the thickness and density of the oceanic lithosphere are age dependent. So the older and cooler it is, the greater its thickness and density. So there's a density of that material. Divergent boundaries that originate from continental spreading produce rifts, like the Rift Valley, of course. So divergent boundaries that originate from continental spreading produce rift valleys, like the Rift Valley in Kenya. East African Rift Valley represents an initial stage of a continental breakup. Arabian Peninsula, no. Convergent boundaries, 3 general types. Continental, oceanic continental, that's where they come together. That's a 2 convergent, they're coming together. There are 3 types of convergent. They're the ones with the oceanic coming against the continental, oceanic to oceanic, and continental to continental. 3 different kinds of convergent boundaries. Convergent boundaries of the lithosphere is continually being generated because the Earth's total surface remains constant, doesn't grow. You'll probably have to remember that. Something must happen to maintain the balance and accommodation of the production lithosphere. Subduction is the mechanism, and subduction zone is where denser oceanic plate is forced under. So they're more dense. The continental crust is less dense than the oceanic. So the oceanic is going to tend to go under. More dense oceanic plate is more dense than the continental plate. Plates subducted angles of a few degrees to almost 90 degrees. The angle of subduction depends on the relative buoyancy of the plates. And you are dismissed. Have a great weekend.